All right. Hi, everyone. Welcome back. I hope that you all had a good break. I hope you all had a good break. Welcome to Comp 2150, Object Orientation. Today we are going to spend a little bit of time taking a look at what this course is about and spend a little bit of time thinking about how we got to the point where we are right now. I want to spend a little bit of time doing just a quick kind of review quiz sort of thing. It's not for points, it's just for fun. And what I want to end with today is spending just a little bit of time walking through and reminding you. I know that you all know how to use Java. Maybe you've never used VS Code before. Almost certainly, you all had to use Aviary at some point. But I just want to take the time to go through and make sure that we're all kind of on the same page with the expectations for how those things work and what we're going to be doing with them this term. First things first, hello again, everyone. My name is Franklin. That's me with the bottom half of my face. The top half of my face looks approximately the same as what you see in front of you right now. My office is E2418. So if you are familiar with where all the computer science professor offices are on the 4th floor of E2, there's one really long hallway that runs behind the elevators, and my office is the one that's closest to the door, that's closest to the stairwell, that's at the corner of E2. My office hours this term are Monday and Wednesday from 10:30 a.m. to 12 p.m. But of course, if those times don't work for you, I'm more than happy to see you at a different time, provided I'm not teaching this class or another class. And if you need to make an appointment with me, you can send an email to that email address right there. So franklin.bristow@umanitoba.ca. I also try to make sure that my office is welcoming to students, and I try to make sure that my door is open as often as possible. Sometimes I can't leave my door open, but if my door is open, that usually means you're welcome to just drop in and say hello and ask a question if you have a question. If you want to take a risk and kind of just show up and hope I'm there, please go ahead. But if you want to guarantee that I'm going to be there, I'll be there in those times. Or if you want to make an appointment with me, I'll be happy to take an appointment. When you are sending me emails, please send me emails from your @myumanitoba.ca email address. I'm usually pretty polite. If you send something by accident from Gmail, I know it's easy to mix it up. So if you do send an email from something else, I'll just politely ask you to email me with your myumanitoba email address instead. Before we get into anything about the class, I want to set some expectations about the classroom, what's going to happen in the classroom, what's expected in the classroom. The first expectation that I have is please wear a mask. This is a university policy. Please wear a mask. If you don't have a mask, I always have lots of masks in my bag. If you get to campus and you realize you don't have one, just come and see me. Come to the classroom and come and see me and I'll give you one. The university also has lots of, I don't know what you'd call them, like tables. Well, yeah, that's literally what you'd call them. There are tables. There are tables at various entrances to the university that just have bags full of masks that you're able to pick up as students. But if you're like, the bus is late and you're hustling it to class, feel free to just come and ask me directly and I'll have some that I can share with you. I ask this politely, please politely wear a mask. The other thing that I have as an expectation is please don't come to class if you're sick for any reason, COVID or not. If you're feeling sick, please just don't come to class. If you were here as I was setting up, you might have noticed that I'm streaming this on YouTube. So if you are not able to come to class, you can tune in on YouTube. I realized when I was setting up that you have to have the OBS window showing to have chat open, so I don't know if I'll be able to handle chat. But if you are on YouTube, watching on YouTube Live, I unfortunately have to kind of leave you as a second-class citizen. You can participate remotely by watching, but I'm not going to be able to answer questions and stuff. I will be able to answer questions and stuff in class. All that said, if I'm sick, I'm also not going to come to class. If I am sick, I am either going to make arrangements for us to have a class remotely. I will make arrangements to have somebody else come and teach the class on my behalf, or in the worst case, I will cancel the class. If I have to cancel the class or change the venue, if I have to teach it remotely, I will send you an email. I will make sure that you know what's going on before it happens. Just for total transparency, I've got a couple of young kids at home. One of them's in daycare right now. And in a completely unrelatable way, little kids, I love my kids to death, but they are they're infection vectors. They get sick, they get sick. They get sick, and then when they get sick, I get sick. I don't really like to get sick. I don't want to get sick. But if I am sick, I'm not going to come to class. So please just keep that in mind. And please be respectful of me and your other classmates and not come to class if you're feeling sick. This course, as with most courses, all courses that you had, has all of the course material up on UMLearn. You should have access to this section on UMLearn, the Comp 2150 section. This section is available for both sections of Comp 2150. There are two sections of this class, and this contains all material for both sections of the class. You are more than welcome to look at the other instructor's material that's posted, just as the other instructor section is more than welcome to look at my materials that are posted. It's kind of up to you to balance how much time you have and how much effort you want to put into reading course material for this course. In terms of this course, you're going to find the course syllabus and schedule. So there's a ROAS, and then there's an approximate schedule of events and topics that are going to be happening throughout the course. I will let you take a look at that on your own time. All of the course notes for both sections are going to be posted up on UMLearn. So the slides that I'm presenting today are up under my section. The link to this live broadcast should be up under my section unless I really messed it up. But all other course material is going to be up there. I'm also going to do some samples in class, and when I do samples in class, I will share the code that I write in class up in the same place on UMLearn. Assignment descriptions, so what you're going to be expected to do for assignments, are going to be posted to the UMLearn page, and we will be expecting you to submit your assignments to UMLearn as well. We're not going to be using Hand-In for this class. We're going to be using UMLearn. So every time you're making a submission for this course, you're going to be zipping up whatever it is you've put together and sending that to an assignment folder on UMLearn. There's also a discussion forum on UMLearn. This is going to be for anything that you have in terms of questions that's related to the course. We as the instructional team, me and Olivier, we have kind of agreed that we want to be politely firm that if you have questions about course material, if you have questions related to assignments, that you should ask it on the course forum. Both Olivier and I will be monitoring the course forum and answering questions. If you feel like there's a question that's maybe like too much, maybe you're thinking that this is too closely related to what you've got and you don't want to commit any kind of academic misconduct by posting something on the forum, then please, yes, feel free to send me an email and ask, but I may politely ask you to ask the same question on the forum if it's okay for you to ask it publicly. If it's an issue that you have about yourself, then of course, definitely please send me an email directly. So if you have a question or a concern about feedback that you've received or a question or concern about grading, yes, absolutely, please feel free to send me an email. In this course, there's going to be a few different things that you are going to be assessed on, things that you're going to be submitting. There are going to be a total of 4 assignments in this course. All of the assignments are weighted equally, so they're all worth 5% of your final grade, and then the total for the assignments is 20% of your final grade. There are going to be 2 term tests in this course, and they have been scheduled on the course schedule. So if you take a look on the course schedule on the course webpage, you can see when these are going to happen. These are each worth 15% for a total of 30% of your final grade. And there's one final exam that's going to be scheduled by the registrar's office at the end of the term, and that's going to be worth 50% of your grade. We do have a late submission policy in this course, so you are allowed to submit assignments late. The penalty is 1% per hour that's late for your submission, and we're only accepting submissions late up to 48 hours after the originally set due date. So to give you an example of what that looks like, if we have an assignment that is worth 20% and you submit it between 0.01 hours late up to and including 1 hour late, you would lose 1% of the grade, and that would be minus 0.2 points from your submission, whatever you received for a score, all the way up to almost 2 days late, and that would be about half of the score that would be deducted from whatever you submit. Academic misconduct is something that's important to everybody. It's important for us. It's important for you. It's important for everybody. In Comp 2150, some examples of things that are academic misconduct on assignments are copying and submitting code that is not yours from another person or from another source of information. So if you find something like a sample solution to an assignment somewhere else, Course Hero or Chegg or whatever, that is, of course, academic misconduct. If you submit something that's generated by Autopilot, that is, of course, academic misconduct. The code that you write for this course must be written by you. It must come out of your fingertips onto your keyboard from your brain. Posting your stuff is also academic misconduct. Now, that doesn't always feel like academic misconduct if you take your stuff and you put it up on GitHub, for example. So if you take your code, and I get it, I really get it, you're proud, you work hard in the assignments, you want to show off, you want to show other people what you did. The code that you write for assessment in courses is something that you should not be posting publicly onto places like GitHub, onto places like Course Hero. There's still free printing, and you can, I guess, technically print out all your stuff on those old dot matrix printers and then go tape it to a wall in the hallway, but please also don't do that. And then any kind of general plagiarism. So if you're copying any material that is not your own and submitting that for assessment as part of this course, that is a form of academic misconduct. Are there any questions about that? We're good? Good. There is an honesty declaration for this course. Have any of you ever had to fill out a paper honesty declaration? Yes? When? Like recently? Outside of our department. Math. Of course it's math. Well, we've entered the 20th century and we let you submit it online. There is a checklist on the course webpage. If you are looking at these notes as a PDF, that is a link directly to the checklist that you need to fill in on the course webpage. You can click on that. The assignment submission folders are all hidden until you have completed the honesty declaration. So if you complete the honesty declaration, you'll be able to see it. If you don't complete the honesty declaration, it will be hidden until you complete the honesty declaration. So please take the time to do that. It's pretty quick. All right. So the coursework, we've got that grade breakdown. We've got 4 assignments. We've got 2 term tests, and we've got 1 final exam. The assignments in this course are all going to be programming assignments. They're all going to be programming assignments. There may be some small written parts to these assignments, but they are not going to be substantial if there are written parts to the assignments. The assignments are all going to involve you designing and implementing object-oriented systems. That means that you're going to be building fairly large projects to put together for assessment here. We're going to be doing this with 3 different programming languages this term. We're going to be using Java. The first assignment that you do for this course will be written in Java. The second assignment will be in C++. The third assignment will be in Java again. We'll go back to Java. And then the last assignment is going to be in JavaScript. This is a lot of languages. This is more languages, I think, than you've learned in any single course before. In this class, I'm going to show you as much as you need for these assignments. I'm going to show you as much as you need for these assignments. There may be some things that you will need to spend time learning on your own. When that happens, I will be making sure that you have the resources that you need to learn from to be able to do it. These are also not going to be complete introductions to the languages. So when we're talking about JavaScript, I'm not going to be like whipping out a textbook and slamming it down on the table and then reading the textbook to you about how to build JavaScript applications. The Java books that you can get are hundreds of pages long. I don't really want to spend all that time talking about how to build Java applications themselves. The assignments that you're going to be putting together for this course, you're going to be looking at them and you're going to be seeing them as pretty big compared to the other assignments that you've done in other courses. The assignments in this course, fortunately or unfortunately, they kind of have to be big. They have to be big because the kinds of problems that you need to use OO for, object-oriented programming, this style of programming, kind of requires that you are looking at fairly large and substantial problems. Yes, please go ahead.
2 questions.
Yeah.
Just to confirm, we're not going to be submitting assignments or dealing with Aviary, will we?
I'm going to repeat your question just to make sure that it's on the mic. The question is, we're not going to be submitting assignments on Aviary, and we're not going to be dealing with Aviary. You won't be submitting assignments on Aviary, so you're not using hand-in. You're going to be using assignment folders on Learn. You do have to interact with Aviary, though. All the code that you write, so all the Java code that you write, all the C++ code that you write, all of the JavaScript code that you write has to run on what's installed on Aviary. The reason for that, I know that kind of sounds painful. I agree. It's kind of painful to have to go and put everything on this other system and make sure that it works there. The reason for that is, I mean, if you're here right now, look around and look at all the different laptops. Some people have Macs, some people have PCs, some people have Windows 10. How many people still have Windows 10 on their laptop? Good, you should probably keep it that way.
Is 11 still bad?
I had it installed on this laptop and I don't know, I don't have it installed on there anymore. If that gives you a sense of my thoughts on that, yeah. I know it's painful, but in terms of we want everyone to have access to the same environment, to the exact same environment. Aviary is that exact same environment. So the version of Java that's installed on Aviary, that's the version of Java that you have to use, or it has to work with, it has to compile with. The version of the C++ compilers that's installed on Aviary, that's what it has to work with. The version of Node and the JavaScript interpreter that you'll be using on what's installed on Aviary, that's the one it has to work with.
And other question, I noticed on Learn, under the communication tab, for some other courses, there's a class list with like student and instructor emails. It's pretty good because then you can just send an email to everyone for a Telegram group or something of the sorts, but it doesn't seem we have access to that.
So I have to be honest, I'm not the course director for this course. Olivier may have disabled that. I can say that Wix and CSSA are going to be coming next class on Thursday, and that is one way that you can get in touch with each other. You can connect. They have a Discord channel set up, CSSA does, and that's one way that you can all collectively self-organize around Telegram if that does not get turned on for you. Good. Any other questions? All right. So yeah, the assignments are going to be fairly big compared to what you've been doing in other courses. They're not necessarily going to be conceptually difficult. They're not going to be like hard algorithms. We're not going to be necessarily looking for massive data structures. I don't know, what was the trees that you were doing in 2140 last term? Did you do 2-3 trees? Yeah, we're not going to get you to do 2-3 trees. That deserves a round of applause. Yes, thank you. Okay. It's going to be big. Yes, it's going to be big. There will be lots of code, but it's not going to be like conceptually difficult stuff. It's just going to be substantial amounts of code that you're having to put together for this. And then yes, all assignments must compile and run on Aviary. And part of this today is I want to show you how I would expect you to compile and run something on Aviary. That's something that I'm going to do today to make sure that you're all on the same page. For Java, when we start talking about C++, I will do the same thing. When we start doing JavaScript, I will do the same thing. I will make sure that you have the tools that you need to get the assignments done. All right. So that's kind of enough, I think, about the course itself, the course structure, and what you should expect. Now the question is, why are you here right now? I mean, I know why I'm here, and I also kind of know why you're here. You have to be here if you want to get a computer science degree. Yeah, okay, so that's why you're here. You want to get a computer science degree, so you have to take this course because it's required for your degree program. But why are you really here? Why do you want to take this course? Why do we make this course a requirement for a CS degree? What the heck even is object orientation? Here are some of the course goals that are listed on the course description for this course on the computer science homepage. What we want you to be able to do by the end of this course is understand the benefits in terms of code readability and maintainability of compartmentalizing code into different objects and hierarchies of classes. We want you to be able to write large object-oriented programs divided into multiple files in Java, C++, and a dynamic programming language. And spoiler, it's JavaScript. We want you to be able to make use of object-oriented concepts like abstract classes, polymorphism, encapsulation, and overriding in an efficient manner. And we want you to begin to understand the advantages and disadvantages of different programming languages. So what the heck even is object orientation? Here's the really simple explanation of what object orientation is, OO. Object orientation is a style of programming. It's a way to do programming. You know a bunch of different languages. You know Java, and C. Okay, you know Java and C. Maybe you know some other programming languages. Object orientation is a style of programming, and it's a way to build software with the primary focus on, we're really looking at modeling data and information. And we're really looking at modeling data and information and its relationships with other data and information. That's the really, really like kernel of what object orientation is. We want to be able to model objects. We want to be able to model things. We want to be able to model the relationships that they have between each other, how they interact with each other, and how they're related to things in like a parent-child sort of relationship. The questions that we really want to try and answer when we're thinking about object-oriented programming are, what's the best way to represent this thing that I'm trying to model in my computer program? How should I take information that I've gotten about this object that's in the system that I want to create, and what properties should I put in it? What does it need to be able to do? How is it related to other things? I didn't say anything about programming languages in that first one because that's kind of a separate point. I want to be able to know what's the best way to represent this thing. And then I also separately want to know how to do that in a variety of different programming languages. How do I make a thing in Java? How do I make a thing in C++? And how do I make a thing in JavaScript? How do I do this in different programming languages? How do I do this idiomatically in different programming languages? Does everybody know what that word means, idiomatically? Thumbs up if you do, thumbs down if you don't. It's totally okay if you don't. Okay. Idiomatically, in spoken language, when I'm talking to you in English, when you're speaking to me in your language, if you speak a different language, an idiom is a way to say something that only really makes sense in that language. So an example of that is when it's raining heavily outside. In English, I would say, it's raining cats and dogs outside. If you translate that literally into French, it's something like, oh gosh, this is bad, I'm sorry. Il pluie des chiens et des chats. But that literally means cats and dogs are falling from the sky. An idiom in English is something that we kind of all understand what that means when it's spoken in English, but if we translate that literally into some other language, it doesn't make sense anymore. In French, I forget what the phrase is. It's something like it's raining nails. That's another way to describe a type of rain. I've fixated on rain here. But if you say it's raining nails in English to somebody, they're, what are you talking about? That doesn't make any sense. Somebody like tipped a bucket over that was full of nails from a skyscraper, and now it's raining nails. Doing OO in Java idiomatically is different from doing OO in JavaScript idiomatically. The way that object orientation is implemented in those languages, the way that it functions, and then also literally the syntax that you're using is different across these different languages. C++ has many more ways to express ideas about objects than Java does. It has many, many more ways for you to express an idea about how an object has relationships with other objects than Java does. So we want to answer this question, what's the best way to represent this thing? But also, what's the best way to encode that representation in these different languages that we have? And how does that compare across these different languages? We are going to be spending a lot of time learning terminology. We're going to be looking at a lot of different words to describe how to model information, how to model data, how to model things. And the reason for that in this course is that we want all of you to be able to communicate effectively with each other, with people like me, and with your coworkers when you're getting into a workplace. We want you to be able to communicate ideas about OO, objects and their relationships effectively with other people, with other human beings. So we're going to be spending a lot of time looking at terminology. And I apologize in advance, that can be kind of dry sometimes, but you got to know the language to speak the language with other people that are talking about the same thing. We also want to be able to model the relationship between things. So like I said, we want to be able to think about how this thing is related to another thing. So I am a thing, I'm a person. I have a laptop, it's a thing. I interact with that thing by pressing buttons on the keyboard. I am asking this laptop to do stuff for me by pressing buttons on it. I am interacting with that thing. I have a child, I have 2 children. This is a bad example. Yeah, I don't know, I have a child. I got 2 kids. What's our relationship to each other? I mean, they're also things. That's really bad. They're people that I interact with, but genetically, that's what I'm actually thinking about here. Genetically, we are related to each other. They're kind of like a copy of me, sort of. They're kind of a copy of me, sort of, and they have similar facial features to me, sort of, but they also have similar facial features to their mother, sort of, but they're slightly different, right? We've got 2 kinds of relationships that we're trying to model between things. Just completely separate things that need to interact with each other, but also the genetic relationship between things. So how do we take this one thing and show that another thing kind of gets derived from that? So saying that one class is related to another because it is that thing. It is that thing. How do we model how those things interact with each other? And part of this is going to be, we're looking at just calling methods. We're calling methods on objects, and we're asking those objects to do things. It's also going to be thinking about how this gets implemented in programming languages and the steps that a programming language has to go through to make decisions about what method is actually being invoked. So what thing is being called when I call this method? What code actually gets run? And trying to think about the relationships between all of those things together that way. So to give you a better sense, a slightly better sense. Of course, this is like the first 30 minutes of a class that's 12 weeks long. So I mean, I know you can't know everything about the course, but that'll give you a little bit better of a sense of what OO is. Good. We're going to be spending lots of time talking about these things. So if it doesn't give you a better sense right now, I hope it will over the rest of the term. Okay. Let's spend some time remembering stuff. A really long time ago, really long time ago, you took Comp 1010 or you took Comp 1012. How many people took Comp 1012? Just out of curiosity. Okay, some of you. Were you planning on going into engineering? Yeah? And we convinced you. Good. You're here. Great. A really long time ago, you took Comp 1010, and some of you took Comp 1012. It's been a long time since I took Comp 1010. It was so long that it wasn't even called Comp 1010 when I took it. It was 74-101. But that was my first line of code when I took Comp 1010. System.out.println hello world. There was also all that other crap you have to write around it, you know, public static void main string args. That just rolls off the tongue now. But that was my first line of code. If you took Comp 1010 with processing, I actually looked this up in the textbook because I haven't taught 1010 with processing, but that's what it says in the textbook, that that's your first line of code. You write line and you get a line. I don't even know if it's diagonal. Is it diagonal or is it straight? I don't know. It's been so long. It's diagonal, okay. So you remember the argument order, or you actually just remember seeing the line? Okay, well, that's actually quite impressive. That's great. So you get a diagonal line. That's sort of the hello world for processing. If you wrote it in Python, and Python kind of makes this embarrassing for Java because that's literally all you have to write is print hello world, and you get a running Python program. Those are the first lines of code you wrote. And then you kept going in Comp 1010 or 1012, and you eventually got to like the last assignment in that course. And like I said, it's been a long time since I took Comp 1010, but I'm pretty sure the last assignment in Comp 1010 was probably something related to like searching, binary searching, or linear searching. And I want you to put yourselves back in those shoes. And I want you to think about the data that you were representing in that program. And I want you to think about how hard that program was. And I want you to think about how you spent 20 hours doing that assignment. And then when you go home today, I invite you to look back at that and think to yourself, how did this take 20 hours? Comp 1010 is giving us this introduction to a language. Comp 1012 is giving us an introduction to a language. The goal of these courses is to help make sure that you can tell a computer what to do and you know how to tell a computer what to do. The goal of these courses is for you to get comfortable with using things like repeated and conditional execution. The goal of these courses is to help you get comfortable with the idea of taking a big problem and breaking it down into smaller units, so functions or methods in Java, static methods in Java. You probably weren't doing classes yet in 1010. You might have done classes in 1012 if you took 1012. Eventually, you took Comp 1020. Everybody had to take 1020 here. There's no alternate path. You had to take 1020. And in this course, you continue to learn about programming languages. You learned Java. You took what you got from processing and you realized, oh, hey, processing is actually Java. You took what you learned in Python and then you figured out how to do the same thing in Java. And then eventually you built a bunch of linked lists. You did a bunch of error modeling and handling. So dealing with file input and output, try and catch, different kinds of exceptions. And you did eventually start to do OO. You started to do some kind of OO stuff. You were modeling some relationships, you were modeling methods, and you were doing some basic OO stuff. And then you got to second year. And I don't mean to like reopen fresh wounds here. I really don't mean to do that. For those of you that did take 2160 last term, or any term, I don't know, sorry. You will, next year anyway, next year, you'll be able to look back at 2160, and yes, C is a hard language. I'm not even gonna like try to candy coat that. C is a difficult programming language. And what I like to say about C is that this is an idiom. There's this idea of shooting yourself in the foot in English. You do something and you like mess it up really badly. What I like to say about C is that programming languages like Java try to help make sure that you don't shoot yourself in the foot when you're writing programs. They give you things like exceptions and index out of bounds exceptions, really specifically index out of bounds exceptions. They try to help make sure that you don't shoot yourself in the foot. C helps you aim the gun at your foot. C it's a fine programming language, and what you can maybe pull yourself out of now is that the stuff that you did in this course, in terms of assignments and stuff, it's actually the same level as 1020. Yeah, yes, there was absolutely new stuff. There was some new stuff that you learned in 2160. You hopefully learned a little bit about testing. You hopefully learned a little bit about this idea of design by contract, adding assertions to your code, preconditions, postconditions, and invariants. Technically, though, there's nothing more than linked lists in this course. There's nothing new there in terms of data structures. Yes, there's a new language, and yes, it looks weird when you've got asterisks and ampersands everywhere, and you're desperately trying to figure out which one goes where. But 2160 is 1020 material again, in a different programming language, with some extra stuff to try and help you take that gun and point it away from your foot, slightly anyway, so you're only taking off one toe instead of all of them. Of course, these words probably became the bane of your existence by the end of the course. You hopefully won't have to see those too much this term. In C++, you can see these words, but C++ tries to, again, help move the gun away from your foot so that you're not pointing it directly at it. So again, I'm sorry about 2160, but it is what it is. And then we're going to make a gap, okay? So we're going to have the question mark that is this course. Eventually, the goal for this course is that it is a direct prerequisite for Comp 3350, which is Software Engineering 1. In this course, we're going to be giving you assignments that are about the limit of where you as an individual can build stuff in terms of the size of the domain that we're giving you to represent in the assignments that we're getting you to build. In Software Engineering 1, you're going to be building a project that is more complex than what we're doing in this class. You're going to be working on a team, and you're going to be building software that's not just for you. When you get to Comp 3350, when you start getting into some third-year courses, it's going to be a lot less about, I'm going to build this code for this assignment, I'm going to put it in a zip file, and I'm going to chuck it at the markers and then get a grade back eventually. It's going to be a lot more about, I want to work with people and build software for people, and I want to make sure that I'm building something that I can keep building over time and making better and working with humans and not just faceless graders. They are people. I promise they're people. The stuff that you're doing in this course is directly related to what you will be doing in Comp 3350, in that it's going to be about software design. It's going to be about building big systems, and it's going to be about working together on a team. All right, I have shouted at you a lot about the course. What I'd like to do right now is spend a little bit of time doing a quick review of some of the stuff that you might have seen in the last couple of years. Do you get to pick those avatars, or are they just assigned randomly? You get to, okay, awesome. That's an upgrade. There are 2 zaps in this course. So there's actually 2 zaps in our department right now. Comp 3170 is being taught by a zap, but it's not the zap that you know. It's a different zap. Okay, so this the game pin should stay up at the top the rest of the game. I'm going to start it now. All right, good, cool. So I'll show you this with VS Code, and I'll show you this with Aviary before we end the class today. But the hope for the best part is the most important part of those 2, but it's the one common thing between the 2 of them. So depending on what IDE or what text editor you're using, it's a button that you can click on, and it will just compile everything that's referenced from the one file that you've got. Or if you're running on the command line, you can use this program called javac to compile everything that you've got. Zap and solo at the top. All right. Okay. What even is an object? What even is an object? These are both correct. They are both correct. When we're thinking about Java, absolutely when we're thinking about Java, an object, the thing that we refer to as an object, is an instance of a class. We have a class definition, and what a class definition really is it's a description of what we want our object to look like. When we call the constructor, when we use that new keyword, we're saying, I would like a new instance that looks like this, please. The thing that's behind our programming language will give us something that looks like that. And we can ask it to change its state. We can ask it to tell us stuff about it. We can call methods on it. An object is also an instance of a struct or a record. And this is C. This is C now. If I have defined a struct, it's kind of the same thing as a class. It's kind of the same thing. If you squint your eyes and look, it's the same sort of idea. The difference between a class definition and a struct definition, with what we've got from those courses that we've taken, is a class is a unit that bundles behavior with data. We have methods in a class, and methods can be called to ask that object to change its state. A struct or a record, so literally using the struct keyword in C, that is just a bundle of data, and that's it. It's nothing else. Declaring a struct as a stack variable, or using something like malloc, and then assigning that to that type of variable, a pointer to that type, that is also an object. That is also an object. What we really are saying when we're thinking about this keyword object here is a thing that we get back that looks like the struct, or that looks like the class that we have defined here. So both of those are correct. Zap is still at the top. This is choose multiple things here. All right. Structs do not support encapsulation. Classes do. Encapsulation is this idea that we can have a thing, an object, that can hide internal details about itself from the caller or from the thing that's referring to that thing. When you declare a struct in C, when you define a struct in C, let me use the right language here. When you define a struct in C, you've got type def struct, curly brace, the things that you want inside that struct, another curly brace, and then the name that you want to give it. When you do that, you can't really hide the implementation of that struct from something. Yes, you can do a header file. You can do a header file, and you can declare the initializer or constructor function, whatever you want to call it. You can declare that function, and you can have just pointers to this struct. And you can kind of sort of hide its implementation, but it's not enforced by the language. You can still just look at memory and do whatever you want with it in C. Java has that keyword public, and it has that keyword private. Private things within a class literally cannot be called. You just can't. You could try, but it's a compile time error for you to even try doing that. Structs don't support this idea of encapsulation because you just have access to the memory. You can just do whatever you want with it. Classes enforce this both at compile time and at runtime. Structs cannot extend other structs. Classes can extend other classes. Yes, this is absolutely true. There's literally that extends keyword in Java that you used in Comp 1020 to extend classes, to add behavior and data to a class. There isn't really such a thing in C. You just gotta like redefine the entire struct if you want something to be related that way. Classes define behavior. Struct does not. Again, you can kind of bundle them together if you put them in the same file, but the struct is not it's not inside the curly braces that you have for the struct. The functions that you're exposing for this thing are not inside the struct. The methods that you're defining for a class are definitely within the curly braces of that class definition. They are attached to the data itself. Oh no, Zap fell off the top. All right, the state of an object can change over time. Yes, the state of an object can change over time. We've got a struct, we've got a class. The state of our object, whatever we're doing this in, C or Java or whatever language, The state of that object is the value that all of the properties within that thing have at any given time. So whatever value the variables defined in the struct have, whatever variables are defined in the class, what value they have at any given time is the state of that object. And the state of an object can change over time based on what we're asking that object to do to itself or what we're doing to that object with functions that we're calling. This is kind of like a technically correct terminology question that I'm asking. In Java, unless somebody is misspeaking, and I'm not going to say that you were never misspoken to in a class, but unless somebody is misspeaking, you would never refer to these units of code as a function. I would never call something a function in Java. The correct term to describe behavior that's bundled with a class is method. In C, I'll get you in a second, just a second. In C, everything is a function. Everything's a function. In Java, when we're invoking behavior on an instance of a class, we're calling a method. We're asking that object to do something to itself. Yes?
So even if you're using like header files to use a file to create objects, it would still be a function?
In C?
Yes.
Yes. So if you're even if you're using a header file and you're exposing only the interface, you're still using function definitions in that interface, in that header file.
So what actually makes it a method then?
The method term is a unit of code that's operating internally within an object.
Okay.
So in C, when we're talking about functions, the first thing that we almost always pass to that function is going to be a pointer to the object that we want to make changes to. When we're defining an interface, I should say it that way. When we've got an interface for a list, for example, the first argument that we put in that list function definition is almost always a pointer to that list. When we call methods on an object in Java, we don't. That's the thing that we're invoking the method on.
So a method is internal, but a function would be external, like working externally?
Yeah. So a good way to think about this is that a function requires that you give it everything that it needs to do. A method implicitly has this idea of the object that it's operating on.
It belongs to something?
Yes, it belongs to something.
Okay.
Yeah. Does that make sense?
Yeah.
Good. Any other questions? We're okay with that? Okay. I hope this is an abstract enough picture for you. Okay, awesome. That's great. An abstract data type defines an interface. And really pedantically, an abstract data type defines the operations that you can do to this thing, that you can do to this type. It doesn't even technically describe an interface. It's just the operations, the things that you can do to this thing. But it doesn't actually implement anything. There is no implementation of the list ADT or the set ADT when you're talking about a set. You can implement a set with a list, but the set ADT itself defines operations on what a set is. This is like moving a lot. This one is really fast. Good, good. Yes, it extends. We use the extends keyword to make we use the extends keyword to define a subclass in Java. All right, here's our last question. Okay, all right. I'm very specifically picking the language ISA here. I'm really intentionally using those words, ISA. We're going to spend more time talking about OO in this course. We're going to spend more time talking about OO in this course. And one of the things that we're going to find ourselves thinking about frequently is this idea of an ISA relationship and a has-a relationship. And there's a difference between these two things. If we have these two ideas, we can have two ideas where each of these ideas are related to each other in an ISA relationship. So I can say something like a data projector is a camera. It's a kind of camera. It is a camera. I can't say that a laptop is a screen. That's not true. I think we all kind of internally know that idea. But we can say that a laptop has a screen. Is a set a list? A set is an ADT. A set is an ADT. A set in and of itself is not a list. And this isn't kind of pedantic. It's pedantic. It's pedantic. It's picky. It's really picky. A set is something that does not define order. There is no sequence in a set. A set is just something that contains a bunch of things. And it either has that thing or it does not have that thing. We can add things to a set and we can remove things from a set. But we can't ask questions about which comes first in the set. There is no first in a set. A list is a sequence of things. A list has an order. There is the first thing in a list. There is the last thing in a list. Think about linked lists. You've got this ordered sequence of nodes. There's a head to your list. Maybe there's a tail to your list. Maybe it's just null. There is a sequence that you've got there. You can implement a set ADT with a list. You probably did implement a set ADT with a list. You can implement a set with a list. You can use a list to implement a set because you can have things like, I'm going to ask questions. If I try to add an object, is it already in my set? If it is, I probably shouldn't add it again. You can ask questions like, I want you to give me the order of it, but now that's your implementation. That's your implementation of what a set is. So very abstractly, is a set a list? No, a set is not a list. A set can be implemented with a list. A set has a list, maybe, but a set is not a list in and of itself. Okay, drum roll. This is really... Denzel, hey, congratulations, yay, okay. This might be like stuff you do every day. This might already be stuff you do every day. But my philosophy is that I really want you to just have the tools that you need to do this stuff. So if you know it, I mean, feel free to tune out. If you don't know it, then please pay attention. And what I'm going to do now is just really quickly write up some nonsense and show you how to compile and debug it in VS Code, how you can transfer it to Aviary, and how you can compile it on Aviary. This is very literally going to be some nonsense. It's not going to be meaningful in any way whatsoever. All I really want is to have two files, so two separate Java files. And I want to be able to run it. I want to be able to debug it. I want to be able to send it to Aviary. And I want to be able to compile and run it on Aviary. That's it. So there's no OO in this at all. It's just how do we do this stuff. So first things first, I'm going to make a new file, and I'm going to call it main.java. If you haven't used VS Code for doing Java development before, so if you've been using, oh gosh, I don't know, do you use like Dr. Java in 1020? IntelliJ, okay. Processing. I really like VS Code. It's extensible in a lot of ways. The first time that you make a Java file in VS Code, it's going to prompt you to install the Java extension pack. And it installs itself and sets itself up for the most part. And it's pretty straightforward to use. When I am doing examples in class, this is what I'm going to use. I'm not sure what Olivier's using. He might be using IntelliJ. But I'm going to stick to VS Code just for simplicity's sake. All right, so a bunch of nonsense here. Public class main, and then public static void main string. I'm going to do final string ... args. You might notice immediately that as soon as I finish typing in that line of code, VS Code is showing me a run and a debug button immediately above that. That's something that's really nice. If you've never seen the final keyword before, this is the same as constancy. This just says it's going to have a value, and I promise not to change it. It's a compile time error if I do try to make changes to it. You may never have seen this ... This is var args in Java. This means that you can call this function with as many things as you want, but that is just an array. It's just an array that you get in this args variable. I'm going to make another file in here. I'm going to call it thing.java. So again, this is not creative in any way whatsoever. I'm going to declare a variable in here, private final string name. I'm going to make a constructor. And I'm going to make a toString function. OK. Whoops. There. Done. OK, that's my Java program. Yay, hooray, a Java program. I want to take my, are we OK with this? Is there something that we're not good with? Good, good. String.format, nice function. You all know printf codes now. Great, good, excellent. Now you can use string.format. Great. OK. I'm going to say here, final thing, thing1 is equal to new thing. Thing1, final thing, thing2 is equal to new thing, thing2. That's one nice thing that I like about VS Code is that it shows you the name of the argument that you're passing to, so it kind of helps you out a little bit. I know that IntelliJ and stuff does this as well. System.out.println, thing1, system.out.println, thing2. I cannot type. Okay, good. Okay, excellent. We have a Java program. In VS Code, we can click the Run button and hope for the best. My output in my console here is fairly tiny, but I promise you that it says, my name is thing1, my name is thing2. In Windows, this will look a little bit different because your console will look a little bit different, but you'll get something similar to this. In Mac OS, it might look a little bit different, but you're going to get something similar to this when you click that Run button. The debugger in VS Code is also very nice. You can click in the column here that has these red dots, and then you can click the debug button. It's setting a breakpoint here. This is, again, kind of tiny, I'm sorry, but we can step over things, and we have variables that are defined. We've got this thing object here. One of the nice things that I also like about the debugger in VS Code is that we can catch uncaught exceptions and caught exceptions. So if we put check marks here, when your code crashes with a null pointer exception, this will just fall directly into the debugger. And you can inspect the state that caused your code to be in that null pointer exception state. You can hit the play button and let it finish. And then that's it. We're done with VS Code. OK, great. Excellent. The other thing that I want you to be able to do is to transfer your files to Aviary and then be able to run and compile them on an Aviary. I'm running Linux on my laptop. I'm running a terminal multiplexer that's called tmux, and my shell is called fish. If you're running Windows, you can install this with basically the Windows subsystem for Linux. You can install the Windows subsystem for Linux and get a lot of this stuff. I'll get to you in just a second. If you're running Mac OS, you can use Homebrew to install fish and tmux if you want to do the same kinds of things that I'm doing in class. Yes? Do I use the command prompt? Yes, absolutely. If you don't want to use VS Code, you can also just do this on the command line. So I've got main.java and thing.java. If you want to just do this on your own machine and you've got Java installed and Java compiler, you can do java c star.java, and it will compile all of the Java files that are in the current directory. And then to run it, you can do Java, the name of the class, and no.class extension. To transfer this all to Aviary, I'm going to change directory to the parent here. The folder that I want to copy is called sample. So I'm going to say scp-r sample to aviary.cs.umanitoba.ca. You're going to have to put your umnet ID before an @ symbol, and then end with a colon, angst.jpg. That's the name of that kid that knows so much in 1020. Hit enter. It asks you for your password. You've all done this before in 2160. It's not going to print anything out when you type in your password, but it's typing something in. You have to be connected to the VPN when you are off campus to be able to do this. When you're on campus, I am not connected to the VPN right now. It will just work. I'm going to SSH to Aviary now. I'm going to change directory to sample. That's the folder that I just transferred to the system. Here are the files. I've got main.class, and I've got a couple of other things because I did this earlier. I'm going to remove my .class files. So I'm going to delete the things that were compiled on my system. Yes, yes, yes. I'm going to do java c star.java. That will compile all of my Java files that are in that directory. I'm going to say Java main, and I will get the same output. You unfortunately cannot do debugging trivially on Aviary, but thankfully, the Java setup is going to be consistent between what you've got on your system and what's on Aviary, as opposed to what you're doing with C. All All right, so really quick summary. I've got 7 seconds left. Comp 2150 is going to be different from other courses. We are going to be focusing a lot more on concepts than how you do programming. There is a lot of programming in this course, but I'm going to be talking a lot more about concepts than programming itself. You already know a lot coming into this course, but there's lots left for you to learn. You should also now be able to use VS Code and the command line tool to build Java programs. Next time, we're going to do a basic OO concept introduction. That's it. Thank you all for coming out, and I will see you on Thursday. Bye, everybody.